assuming we have a strong sampling design, we're ready to move on to the experiment. And so that experiment is going to be highly sensitive to whatever context we're in. However, every experiment needs to have three major principles from statistics in it, or at least accounted for somewhere, so that later on, when they're ready to do the analysis, it will be valid and it will be robust. Okay? So you can see the three principles outlined here. The first one is controlling effects of lurking and confounding variables on the response variable. Okay, and so here, many experimental designs have a treatment, right? That's the whole purpose, is to test the treatment out on the group of individuals that you selected for your sample. Okay, and so we would call them the treatment group, just the individuals getting the treatment. Okay, and you may, in most cases, want a control group to help you kind of tease out any effects that may happen just by virtue of the people that you've selected or whatnot. And that would be where you have a control group. Okay, the control group just is kind of your baseline where you start, or where you always compare measurement to. Okay, the control group, instead of getting a treatment, they would get what you call a placebo, just a controlled treatment that is, it's a treatment that is fake, that has, so if it's a pill, normally, like you give both groups a pill, the control group would just get like a sugar pill, something that doesn't have anything in it. Okay, and otherwise it is indistinguishable. Okay, and then so what you're doing over the course of the experiment is testing out the factor. Okay, this is the book's fancy way of saying explanatory variable on the response. Okay, and hopefully, because of your experimental design, you have accounted for different lurking variables and kind of mitigated their effects to the best you possibly can. Okay, as a way to help control effects of lurking variables, often experiments are either single or double blind. Okay, and so single blind is where the participants don't know which treatment they get. Don't know which treatment. Okay, and this would be in a case where maybe the lead researcher needs to know, like, maybe because it's a life and death sort of situation, or they're measuring side effects or whatnot, who gets what treatment so that they can respond appropriately if they need to. Okay, a double-blind study or experiment would be where both the researcher and participant don't know which treatment. So this would be something where the researcher submits a proposal to the FDA, perhaps, or a different organization, and then they do all the managing of the research for the researcher, and then at the end the researcher just gets de-identified data and kind of works with that for their analysis. Okay, so that all those different things that I mentioned are to help control the effects of lurking and confounding variables. Okay, the next major principle of experimental design is to use randomization whenever possible. Okay, and that helps to eliminate bias. Okay, so this helps to eliminate bias. Okay, and then the last major thing that we need to be aware of is using a large enough sample so that we can reduce any variation that might happen by chance. Okay, so that at the end we can say, okay, if we only use 2 people, okay, and we got 2 very different results, I mean, is that enough? Is that enough to make a conclusion about something, and that, that we did this, and so this is leading us to believe this about the population? Okay, not necessarily true. Okay, so you want a large enough sample to make sure that it's representative of the population and that your implication has some kind of mass or substance to it. Okay, and so if we can satisfy these 3 principles of controlling the effects of lurking variables, randomize whenever possible, using a large enough sample to reduce chance variation. Okay, what we hope to see in the very end is statistical significance. Okay, and this is just the idea that what we got is not by chance alone. Okay, so there's a reason we got the results we did. Okay, and so that's the idea. And so whenever you see the results were statistically significant, that means the results were meaningful, that it didn't happen by chance, that there was some reason that this happened. Okay, and so now with this kind of overarching framework of, okay, you have these goals, you have these principles, how can you design to make sure that you address these three principles and hopefully see statistical significance? Well, that's coming up in the next video.